Hello everyone. I, Siddharth Ohri of Batch 4, would be conducting a seminar on the topic nanotechnology based smart dust, the next big thing in IoT. IoT, or Internet of Things, require both practical as well as bookish knowledge. As we all know, we enjoy it as it is more based on hands on activity. Now we would be talking about the topics covered in this seminar. First, we would be having a brief discussion on the topic nanotechnology. Then, we would be talking about its emerging and an interesting application, smart dust. Then, we would be talking about the technology used in smart dust. We would then be talking about the fabrication of the smart dust. We would be then talking about its working. Communication technologies used in smart dust. See the major challenges faced by smart dust. Its applications. Every coin has two sides. So we would be seeing its advantages as well as disadvantages. Then I would be concluding this seminar. Nanotechnology. Nano, as we all know, means 1 billionth of a part, and technology means the scientific knowledge or equipment that is needed for a particular industry. When both these words combine, they mean the branch of science and engineering which particularly deals with the manipulation of atoms and molecules so that they can be used at nanoscale for designing, producing, and using structures, devices, and systems. Atoms and molecules both have their respective and unique qualities that can be useful in many fields. Atoms are the smallest particles of an element which can take part in a chemical reaction. Molecules, on the other hand, are the smallest part of an element or a compound which can exist independently. It is also a science of building small and can also be used in real world application. Nanoscience or nanotechnology can reshape the world around us. When we think about things like the food we eat, the house we live in, the car we drive, are all made up of atoms. So think how a car works. The arrangement of all the parts in the right manner makes the car work efficiently and smoothly. In the same manner, the arrangement of atoms determine the working of anything around us. It is just like joining puzzles to make the perfect picture. Things started to get interesting for me when I thought that every matter have different properties and they change when they are shrinked. We know that when working on a nanoscale, the properties of the matter are size dependent and are hard to compress them. Scientists and researchers are regularly working and are also able to make nanotechnology and applicate them in the real world. Nanotechnology is also often used for increasing the efficiency of energy consumption, help clean the environment, and solve major health related issues. Now we would be seeing some applications of nanotechnology. Nanotechnology can be used in optical engineering and communication, biotechnology, textile industry, energy storage, defense and security, metallurgy and materials, biomedical and drug delivery, and at the last, cosmetics and paints industry. We would now be seeing that how is nanotechnology used in various fields. Nanotechnology has its own application in medical field. It can be used for making nano knives as it nano-invasive method of destroying cancer cells with high voltage electricity, and also we can make carbon nanotubes that are already used for repairing. High strength corrosion resistant coatings are another military use for nanotechnology in order to improve durability, corrosion resistance, and reliability. At the nano level, physical, chemical, and biological properties of materials differ in fundamental and valuable ways. Nanotechnology attempts to exploit these differences to create new biomedical research tools, diagnostic tests, and drug delivery systems. These are some emerging fields, and nanotechnology can surely play a major role in developing of these fields as well as making these fields more efficient. Think and imagine if we can get all wireless devices as small as a grain of salt. These devices have sensors, cameras, and collect data. Micro electromechanical systems have somewhat done the job. They can detect everything from light to vibrations to temperature. They can accommodate in them things like autonomous power supply, sensing, computing, and wireless communication in a space that can be suspended in the environment just like dust particles. So from here, it gets its name, smart dust. Smart dust also contains tiny sensors which contains computational capability. Smart dust concept has been credited to a researcher from the University of California, Berkeley, in 1997 by Professor Chris Pfister. Now we would be seeing the technology used in smart dust, that is micro electromechanical systems. Integration of mechanical elements, as the name suggests, sensors, actuators, and electronic on a common silicon substrate through microfabrication. Two things are used in its fabrication, electronics and micromechanical. The techniques used are IC process technique and micro machining technique. Now we would be seeing the technology used in smart dust. The sensors, beam steering mirrors for optical transmission, corner cube retroreflector for passive optical transmission, an optical receiver, signal processing and control circuitry, a power source based on thick film batteries, and solar cells. Now we would be seeing the fabrication of smart dust, it with a protective layer and is being divided in two parts, porous silicon and hard silicon. It consists of a micro power supply, two sensors, and a MEMS actuator, that is micro electromechanical systems. The DC-DC converter in the micro power supply is fabricated using the 0.8 mu meter. It is being fabricated in France. Now we would be seeing the working of smart dust. It is being run by a microcontroller. It determines the task performed by the modes. It also controls power. Primary constraint of smart dust volume. It has a constraint on energy. Microcontroller consists of various tiny sensors for recording various types of data. These sensors are run by timers. When a timer expires, it powers modes to carry out the job and then automatically powers off. Data is sent to base controlling sessions. Corner cube's retroreflector is built by using MEMS or smart dust. Here we can see some of the components of smart dust. The first picture we see is a passive transmitter with corner cube retroreflector. Then active transmitter with laser diode and beam steering is used. We also need a receiver with photodetector, analog input-output, DSP control, power capacitor, solar cell, and thick film battery. Now, we would be seeing the communication technologies used in smart dust. Radio frequency transmission, optical transmission technique, passive laser-based communication, active laser-based communication, and fiber optic communication. Now we would be seeing radio frequency transmission and its explanation. Based on the generation, propagation, and detection of an electromagnetic waves of range of tens of kilohertz to hundreds of kilohertz. Multiplexing techniques, time, frequency, or code division. Their use leads to modulation, band pass filtering, demodulation circuitry, and additional circuitry, all of which needs to be considered based on power consumption. Now we would be seeing what are the major challenges that smart dust faces. As we all know, it is difficult to fit all the devices in a smart dust, both size-wise and energy-wise. With these devices so small, batteries presents massive addition to the weights. These are some of the real-world applications of smart dust. Environmental protection, habitat monitoring, military application, in medical field, security, virtual keyboards, monitor traffic, and many more. As we all know, every coin has two sides. So here we would be discussing about the advantages and the disadvantages of smart dust. Smart dust does not require unbroken line of sight and the link directionally. Communication between the dust motes and base stations can be guaranteed. It has a longer range of communication link than that of a free space passive optical communication. As we all know, it has small size, better connectivity, and is also cheap, that is low cost. Now we would see the disadvantages of smart dust. Privacy of a person is hampered. Security of information cannot be handled. Optical fiber cable restricts the movements of the dust motes. Since a base station should employ several optical components for fiber connection to each dust mote, it may complicate the base station design. Now, we would be concluding this seminar, and there are many researches going on smart dust, and the main purpose of all the scientists and researchers is to make smart dust as small as possible and to make it available at a low price. Soon we will see smart dust in various applications from every span of life. Thank you very much, and I hope I would be able to enlighten you all with this topic.